Good morning, class. Today we are going to talk about one of the most important parts of any modern robot, the microcontroller. A microcontroller is an integrated circuit, a small, powerful chip that can be programmed to perform a specific task. It receives inputs from sensors, processes the information, and produces outputs to control motors, LEDs, displays, and more. Think of the microcontroller as the brain of the robot. Microcontroller in a washing machine controls timing. Microcontroller in a drone stabilizes flight. Microcontroller in your Arduino projects reads sensors and moves servos. A microcontroller is like a mini computer in one small package. It typically includes CPU, processes instructions, memory, flash, stores programs, RAM, temporary storage, input, output, pins for sensors and actuators, timers for time-based tasks, communication interfaces, UART, SPI, I2C, etc., analog to digital converter, reads analog signals. A microcontroller is a self-contained computer designed for one job. An embedded system is a combination of hardware and software designed to perform a dedicated function. Examples: microwave oven, anti-lock braking system, line-following robot. Key characteristics: task-specific, real-time operation, limited resources. Every microcontroller we use in robotics is part of an embedded control system. Explain that sensors often produce analog signals, but microcontrollers understand digital signals. Converts a continuous analog signal into a digital number. Allows microcontrollers to read values like temperature, light intensity, or motion. A light-dependent resistor outputs varying voltage. ADC converts this into a numeric value. Digital interfaces carry digital signals, either high or low. Used for buttons, digital distance sensors, switching LEDs, or motors on-off. When you press a button, the microcontroller receives either a 1 or a 0. SPI is a high-speed communication protocol used between a microcontroller and peripherals. It uses 4 main lines: MISO, master and slave out, MOSI, master out slave in, SCK, clock, SS, slave select. Applications: SD card modules, high-speed sensors, displays. SPI is fast and ideal for devices that need rapid data exchange. Microcontrollers often communicate with a computer through serial communication, usually UART over USB. Uses uploading programs, sending sensor data to PC, monitoring, debugging information using serial monitor. Arduino uses a USB cable to communicate with the Arduino IDE on a PC. When we talk about code integration, we mean combining sensor input, logic, and actuator commands into one functional program. Steps: initialization of sensors and pins, reading sensor inputs, processing in the microcontroller, outputting signals to motors, LEDs, debugging using serial monitor. If you were to design a robot that reacts to changing light, what type of microcontroller, sensor, and communication interface would you use, and why? Thank you, and have a good day.